Hey, Dr. Hines here again. We can always have a little bit of fun on these videos here. We don't have to be so staunch and everything. But what I'm about to do here is I'm about to carry out several steps in the procedure here. Basically what I'm going to do is I'm going to prepare the vinegar sample for the titration process. And I'll just kind of go through the steps right here. So here's our unknown acetic acid. We've got it labeled as unknown acetic acid, but you know, this is what you buy at the grocery store. It's just vinegar. So in theory, we kind of actually already know what the concentration of this should be. Now, me being an analytical chemist, okay, and actually this is even just general chemistry good practice right here, okay? I'm gonna get a sample of acetic acid out of this bottle, okay? Do not take this piece of glassware, which I'm wondering if you remember what this is. This is called a pipette. It's a volumetric pipette, and the volume of this pipette is right there stamped on it, so there's no mistaking how much vinegar we're gonna use. Now, you never, ever want to dip the pipette into your sample. You don't want to risk any kind of contamination. So good procedure says you should take some of your sample and put it in a clean and dry beaker. And by doing this, I've maintained the integrity of my original sample. So what I have in my beaker, if I mess this up, well, that's okay. I can dump it out, and I know I've still got a good sample to work with. All right, so I'm gonna want 5 milliliters of this, and I'm gonna put it in this piece of glassware, and I'm wondering if y'all remember what this is called. Dun, 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 dun. This is called a Erlenmeyer flask, okay? It's already been cleaned, it's already been dried, it's ready to go. So I'm just gonna put 5 milliliters into the Erlenmeyer flask. Now this is how this works. And this is one of the things, do you know what this is called? Do you remember what this is called on your equipment list? Okay? This is called your pipette bowl. They come in many different sizes and shapes and functions right here, but basically there is a specific way it goes on there. It does not go on there like that. It goes on here like this. Okay, bulb at the top, there's this little sidearm looking thing right here. And man, I really wish y'all were in lab, because this is one of my favorite parts, to see y'all struggling, working this thing right here, and I just have to sit there and do my head like that. But anyway, so I'm gonna show you how this works, all right? First, we gotta get the air out of the bulb. How do we do that? Squeeze this thing called A. A stands for air, aspiration. I like that letter of the alphabet. So I'm gonna squeeze the A. There's a little glass bead in there, and when I squeeze it, it opens the valve, and I can let all the air out of this. And then when I release the A, oh my goodness, I think this is ready for suction right here. So that's what the top valve is for, is getting all the air out of your pipette bulb. And we would let you practice this. I mean, we're not gonna expect you to do it correctly the first time. You just kind of keep playing around with it till you feel comfortable that you can do all these steps right here. Now I want to suck the liquid up into the pipette. Now, this being a volumetric pipette, I'm gonna bring this up close one more time. Right there above my fingernail, you'll see a little mark. When you fill that up to that mark, and remember the little meniscus thing there? When you fill it up to that mark, this should be 5 milliliters in here. So that is what I'm gonna attempt to do. So I put the pipette into my vinegar. Now how am I gonna suck it up in here? Well, underneath the bulb, right here, I don't know if you can see it, but it says S, suction, okay? Very gently, don't try to, you know, like you were born in a barn or something like that. Just very gently squeeze the valve, and oh my goodness, it's sucking it up in there just like a soda straw. So if I squeeze it gently, I can get this liquid right up to the mark. Can I do it? I'm an analytical chemist. Can I get it the first time? I don't know. Do I got the meniscus on the mark? I look down, ooh, score the PhD degree. Okay, so now this has got the 5 milliliters in it. All right, I just simply want to transfer it over into the Erlenmeyer flask, okay? All right. Don't be flinging your pipette around, okay? Very gently, just move it over to your Erlenmeyer, and now I want to empty it. Oh, well, what letter of the alphabet do you want to use for empty? Looky right there, there's an E. Let's squeeze the E right here. You just squeeze it, it drains in there, and my, that was just so easy to do. I'm gonna let it drain. And another analytical technique right here is you let it drain. You do not force the liquid out of the tip. Notice how there's still a little bit of liquid in the tip, okay? They know, whoever it is that manufactured this pipette, they know that a small portion is gonna remain in the tip, and they've already got that factored into the mark right here. So there we go. One more quick thing here. We're almost done with this. I've got the sample in here, and I'm gonna add a few drops of indicator here. So let's see if we can get a good close-up of that. This is called phenolphthalein. When this reaction occurs, you're not gonna be able to see it occurring. So we add something called an indicator, and the indicator will change color when the reaction is done. So I'm gonna finish this off by putting 3 drops in here, just 1, 2, 3. Okay, the more drops you put in there, probably the darker it will turn out, but anyway, put some of that in there, swirl it around, and now we are ready for the titration process.